Hey guys, okay, this is your instructional video on water quality. This is section 2 of this unit. Now the whole unit is kind of under the umbrella of water quality, but this section gets into how we ensure our water is of a high quality and what we're looking for, okay? All right, so go ahead and write that down in the next blank page of your interactive notebook, and if any point in this video you have to pause it to record some of your notes, please do so. The videos I have embedded on your weekly planner slide, on the activity slide. So please, please, please make sure you go back and watch those because they're a little long and I don't want to put them in this portion, but I do need you to watch those because they explain step by step some of the filtration systems. And one of them is really funny. A guy dresses as a poop. So it's kind of funny, but I do really need you to watch those so you're very prepared for the test and such, okay? I know we don't like to talk about this stuff, but we've got to. You've got to know how clean your water is and why it's that clean, okay? I know some of you don't care to know, but you should really know. Okay, here we go. All right, so the acidity of water is very, very important, okay? Now, the pH determines the acidity of our water, okay? Some of you that have, over the years, had a swimming pool, if you've ever had to test the water, then you know you're probably testing the pH level, because if it's too high, the water's getting a little too basic. If it's too low, it's getting too acidic, and it's on that scale of 0 to 14. Now, both, if it's too basic or too acidic, both can cause problems if you're swimming in that water, because a lot of times it can cause like your skin to break out and maybe a rash or something, or get really flaky and dry. And nobody wants that because that's yucky. Okay, so that's one thing, and is the acidity. The other is, in water quality, is the hardness of the water. And this is especially difficult to manage in well water. And I know a lot of you had shared that you are on well water at your house. So your filtration system on your private well probably has a standardized filtration on there that determines the hardness of the water. And what that means is it's the concentrated amount of the calcium deposits, the dissolved calcium, and magnesium deposits, the minerals, okay? If it's too much, that's not good. It's not good for you, and it's also not good for your pipes, because those dissolved minerals can get can calcify and get stuck in the pipes, and it can clog your pipes, from keeping the water flowing freely. So your private well most likely has some kind of filtration or system that is on there that makes sure that the hardness of the water doesn't get too high. Okay, so I don't really think it's something that you have to worry about. Okay, all right, so those are two of the things. Now here is an example of the pH scale from 0 to 14, and there are a few things that are on here: battery acid, lemon juice, vinegar, orange juice. And we think to ourselves, oh my gosh, I drink orange juice. It's acidic. I'm drinking acid. Well, yeah, all citrus fruits have a high acidity level, higher than other fruits. Like a banana is not going to be very acidic, but an orange is, or a lemon. So that doesn't mean that that's necessarily really bad for us and it's going to kill us. Battery acid, yeah, don't drink that. That's going to kill you. But lemon juice, usually we're watering that down. So it's a low concentrate, it's diluted. Orange juice, same thing. And you're not only drinking orange juice all the time. You are drinking it, maybe a glass a day or something like that. If you drank a lot of orange juice, like if you drank as much orange juice as you drink, as you're supposed to drink water, 64 ounces, then you're going to have a problem. You're getting too much acid in your stomach. And also, the higher the acid, the more enamel, it can affect the enamel on your teeth. So you have to be very, very careful about that. Okay. Black coffee is acidic. Remember, the safe range of, like we said up here, of acids is 6.5 to 8.5. Most of the time when you drink water, it's going to be right around a 7. Okay. Right smack in the middle. That's neutral. Okay. But sometimes the water can be a little bit below 7 or a little bit higher, and it's still safe to drink, okay? But when you're getting down to black coffee, things like that, that is very acidic. And so that's why sometimes, when people, like I drink coffee, but I always follow it up with water. And we were talking about this in class one day, that when you drink an acidic beverage, like soda is very acidic, all kinds of soda, especially citrus sodas like Sunkist or Sundrop, things like that. Or if you're drinking orange juice or you're drinking black coffee, it's always a good thing that after you finish that you drink some water after that, because that will clean your teeth. It'll wash off any of the residual acids that have gotten onto your teeth, because if they just sit there, then they're going to eat away at the enamel, not immediately, but over a long period of time if you're a long-term drinker of sodas or coffee and things like that. So it's always good, to drink some water afterwards, okay? And then when you get into the bases, like oven cleaner, bleach, ammonia solution, soapy water, you're starting to notice a pattern. A lot of soaps, baking sodas, they're a base, okay? So when you combine a base and an acid, you make it neutral, okay? Like vinegar and baking soda, we get that reaction like we had with the balloon that we did a couple months ago, blowing up the balloon. That's because the water becomes neutral, or the liquid, the solution becomes neutral, because you mixed an acid and a base, okay? We'll get more into that also when we cover chemistry. Okay, and this is just another way to look at the pH scale, okay? All right, coliform count is very, very important in our water quality. This is the concentration of our disease-causing organisms, especially they're looking for E. coli. E. coli, and yes, that is a little E. coli bacteria cell, okay? It looks like a little hairy monster, and that's kind of what it is, because it can make you very, very sick. E. coli, as some of you may know, is found a lot in poop. Okay, so when we get E. coli bacteria, often in lake and river waters, and that's because of runoff. Like we've talked about before, the animals in the forest, when they gotta go, they gotta go. So they go, and they go number 2. And when it rains, that number 2 washes out into the lakes and the rivers. And that's our reservoir. Or it has sat on the ground and it rained, and that bacteria seeped down into the soil and gets into the aquifer, into the groundwater. So we've got to get that stuff out. We don't want to be drinking that. That's going to make us very, very sick. Okay. So in comes the filtration system. Okay. Oh, before I go to that, the coliform count in a reservoir, and this is true too for your well water too. You've got this on your well water too, the filtration system. But in a reservoir, when it's being filtered and it's checking for E. coli and the coliform count, it can't have any more than 1 of 5 tests positive, and they're pretty much testing every 24 hours, or every hour of 24 hours. So if they do 5 tests in 1 hour, one of them can come back positive for E. coli, but then they're going to follow it up with 4 more. So the next 4 have to come back negative, okay? And if anything, I know, because I've visited the control center and the wastewater treatment plant in Hickory, and so I know this, that they have an alarm system basically on that coliform count. And if one comes back and it tests positive, like a flashing red light or a siren or something goes on, and then they check it again immediately, 4 more samples. And if another one of those 4 comes out positive, they have to shut the pump down. Okay, and they've got to figure out what's going on, because that is some serious stuff. If E. coli bacteria gets in our drinking water, it's some serious stuff. We can get very, very sick, and that goes out to not just one, but thousands of people if we're on a reservoir or if we're on a community well. Okay, so how do we get all that junk out? Filtration, simply put. But it's a very long process, which takes about anywhere between 24 to 48 hours to filter the water once it comes in to the wastewater treatment plant, okay? Now, a couple of ways that they do this. Activated carbon is something that they use quite often. It's like tiny little holes that are in charcoal. And when the water passes through it, it can capture those harmful wastes. If any of you have a reusable water bottle that's got a filter on it and you have to change out the filter, guess what's in that filter? Activated carbon. If you break it open, you'll see all of this black granular stuff. That's activated carbon, and it's good for filtering water. You're not drinking any of the carbon, don't worry, because that would make you sick, but it does filter out all those harmful wastes and things that should not be in your water. Okay. We also treat our drinking water. I don't know why I have AA. I just noticed that it should be AB. Apparently, I don't know my alphabet. Sorry. Okay. So you put AB. All right. Chlorine is the chemical that is added to the water to kill the bacteria. Just like we add chlorine to pool water sometimes to kill bacteria, we add small amounts to our drinking water. Now, if you are on a private well, you probably do not have chlorine added to your drinking water. But this is drinking water that's coming from a community well or a reservoir, okay? But usually most well water, especially private well water, does not have chlorine added, okay? All right, so this, make sure you watch this video. I call him Splash. He's a little drop of water, okay? It's a very good video. It takes you through the whole filtration system, but this is kind of what happens. You pull, and this is if it's in a reservoir, not if it's a community well or if it's a private well. So you've got your water in the reservoir, and that's basically lake water. You're not going to drink that water straight out of the lake. So it goes first through this filtration system where a coagulant is added. And a coagulant are sort of like these little sticky flocks that will stick to all the bacteria. And then it goes to the flocculation tank where it spins it all together so that coagulant can start connecting with all the bacteria and debris. Because if it does, then it increases the density of the bacteria. And then what happens is, remember, we've talked about density. The higher the density is, the more it will sink in the water. And then that's what happens in that sludge collector, okay? This sediment at the bottom is all of the bacteria and the coagulant that stuck together and settled. They also call this a settling basin. Sometimes it's called a sludge collector. Sometimes it's called a settling basin. But basically, it settles out all of the yucky stuff with the water. So normally in this separation, you will see a distinct difference in the color of the water from the time it enters the coagulant, adding the coagulant in the flocculation. And when it gets to the settling basin, you'll start to see a clearer water, which indicates that all of the gunky debris is coming out. Now, let me tell you what they do with this sludge thickener. So they take that sediment basin, or all of the sediment, they combine it with a thickener and they load it onto trucks and they use it to grow plants at a horticulture center, at a landfill, okay? So that doesn't go to waste. Now, let's go back to the water. So now the water still, when it's in that sludge collector or settling basin, it's not clean yet, okay? It's not clean. It still has some bacteria and microbes that can make us very sick, all right? Because it's not going to, the flocculation tank is not going to catch all of the microbes, okay? Mainly it's going to collect the ones that are large enough to stick to those flocks, okay? All right, so then we filter the water and it again becomes more clear, and we disinfect the water. And if it's a city water, fluoride is added, okay, to help our teeth, to prevent tooth decay. Chlorine is added and some other things. There's also usually a stage where they call it aeration, where basically it sounds exactly like what it is, it is exactly what it sounds like, where they inject a lot of air, high pressured air, and that's to sort of, I guess, lack of a better term, freshen up the water. That's mainly just for taste, okay? And then they filter, they put the filtered water in storage in like a water tank, okay, which you probably see all over, big cities. You'll see these huge water tanks. That is filtered water that's ready to go out to the residents. Okay, it's filtered, it's clean, and it's ready to go. And then it's distributed, as you can see in the faucet. Okay, all right, so make sure you watch that video. I've put it on the weekly planner. Okay, all right, this is what activated carbon looks like, that little granular carbon. And this is just sort of an animated picture of what it would look, what would happen when those water, when the water is going through the activated carbon, how all these little red things, those are all your microbes. Okay, and it's going to break them apart and make them smaller so they can't come into your water. Okay. As I told you earlier, I went to the wastewater treatment plant that's in Hickory, and this is the control center. Okay, this was several years ago, so I'm sure their computer system is looking much better than it does in that picture. All right, here are the coagulation and settling basins. Now, when you walk out here, it is smelly. It is smelly, smelly water because it's still dirty. But you can see how dark that water is, okay? And this shows you a little bit more of a close-up picture. It's very, very dark. I would never drink that water. I wouldn't even put my hand in that water. It's pretty dirty because that's not only the lake water, but that's also the water that is piped from people's homes. So it's every time you flush your toilet, every time you wash your dishes, every time you take a shower, all of that water has to go through the wastewater treatment plant, and then it's treated, filtered, all of that's happened, and it's recycled, and it comes back to your house. Okay. All right, and then this is where the storage for the fluoride and the chlorine is kept. So very, very, very small amounts of chlorine and fluoride are needed in that water. Okay. All right, and then the next slide, Roman numeral 3, treating wastewater. We call this place a wastewater treatment plant. It cleans the sewage before returning it to nature. Yes, the sewage. That's the sewage is anything basically that goes down any drains in any home, in any business, in any school, whichever. Okay. Now, septic systems. Those of you that are on well waters, you probably know what this is, a septic system. This is basically an underground tank that cleans the sewage from a single household. Now, everybody's got a septic system. The school's got a septic system. I've got a septic system. Even though I'm on even though I'm not on well water, I'm on city water at my house. But basically, it's going to clean that gunk out of my water that comes from my house before it pipes it into the city line and goes to the wastewater treatment. Okay. So basically, it's pulling out all of the stuff like toilet paper, number 2, and anything else. Okay, one of the videos shows you how a septic tank works, and I think that's the funny one when the guy dresses up in a poop costume. So it's really important to note that you need to be careful what you flush down your commode, okay? Because when whatever you flush down your commode, if it's something that's going to clog your pipes, it's going to clog your pipes. So they say that there are 3 P's: poop, pee, and toilet paper. Those are the only 3 things you should be flushing down your commode. Okay. Wipes that you use, like baby wipes or, Cottonelle wipes that they say are flushable. Not really. That can cause a problem in your septic system. So be very careful with those if your household uses those. Okay. But definitely watch that video. That'll tell you a lot. And don't you like how I trained that dog to, go to the bathroom in the toilet? Yeah. No, not my dog. My dog, Rosie, would fall through. All right. So this is a animated picture to show you how it works, but there's also another video, where does it go? So make sure you watch that. So this is a private home. Now, here is their sanitary sewer in the red line. So anything that's flushed out of their home goes to this sanitary sewer. So follow the red line first, okay? Now, what's going to happen is it's going to be piped in, and it goes through what's called a grit chamber, and that's sort of like that settling basin like we were talking about before. And then it's going to go through the primary treatment tanks, where it's going to first filter it and treat it a little. Then it's going to go to the aeration tank, like I was talking about before, where it blows that air into it, mainly for taste and things like that, and to get things to settle out. Then it's going to go to the secondary treatment plant, where it will be treated and clean enough in order to consume or use. And then it's going to number 6, where it adds any kind of disinfectant, okay, as a last resort. And then it goes out, back out of the pipe, okay, and back into our homes. Now, that sanitary sewer system is different than the storm sewer system. If you look at the blue, you see this little vent on the road or in the yard. That means anything that lands on the ground, the road, anything at all, your driveway is going through the storm sewer, excuse me. That's a different pipeline than the sanitary sewer, okay? So, unfortunately for some, that storm sewer is going straight into the lake, okay? So that's why you need to be careful about trash, debris, things like that that are on our roads and in our yards, because they're going straight in to the lake or reservoir or wherever you're connected to, okay? Definitely be sure to watch that video, okay? They are funny videos. All right. We got 3. Acid rain. Acid rain will have a lower pH number than pure water. Absolutely. It's going to be acidic. Acid rain can kill trees, can kill plants, things like that, if it's very acidic, okay? And we'll talk more in one of the next units about how acid rain is formed, okay? Chlorine. Chlorine is a chemical added to water to kill bacteria. That is true, okay? We know that. But we have safe amounts of chlorine that are added to our waters. Number 3, water that goes down a storm drain on a road is cleaned before it goes back into our water supply. Yes and no. It depends on what you define as our water supply. No, it's not cleaned before it goes into the lake, but yes, it would be cleaned before it goes into our water supply that we use when we turn on our faucet, okay? Number 4, some water can be harder than other water. That is true. Those calcium and magnesium deposits, most often found in groundwater, that can be harder. That's the water hardness. And number 5, E. coli is a bacteria commonly found in river water. Yes, it can be commonly found in river water because a lot of it does come from runoff, because it comes from waste, animal waste. I won't say poo anymore. Poop. Okay, anyway, I said it. All right, so make sure you get all those notes, and that is section 2. And sections 3 and 4 will go into some of these topics quite a bit more. So look for that. Watch those videos, and I will see you soon. You guys email me if you have any questions. Okay? All right, take care. Bye.